Welcome dear students. Today we are going to talk about the IUPAC nomenclature of the ethers. Ethers, that is a class of the organic compound in which two alkyl groups or two aryl groups are covalently bonded to an oxygen atom. And my dear students, this oxygen atom to which two alkyl or two aryl groups are attached, this is called as the ethereal oxygen. Now, if the two alkyl groups in the ether they are same, then that will be called as the simple or symmetrical ether. But if the two alkyl or aryl groups attached to this oxygen they are different from each other, then this type of ether is called as unsymmetrical or mixed ethers. My dear students, the name ether belongs to the common system of the nomenclature, and in IUPAC language, the ethers are given a name that is called as the alkoxy-alkane. Now, my dear students, if the symmetrical ether is there, it has two same alkyl groups. So, any one alkyl group with oxygen atom that will be considered as the substituent, and the other alkyl group that will be considered as a parent. Now, the alkyl group with oxygen, it is a substituent and it will be named as alkoxy. Alk from alkyl and oxy from oxygen. And the other alkyl group which is parent, now it is called as the alkane. So in case of the symmetrical ethers, there is no problem because both alkyl groups are same. So any of the one of the alkyl groups along with oxygen can be considered as the substituent and the other alkyl group will be considered as a parent. But in case of unsymmetrical ether in which the two alkyl groups are different, then the rule is that the smaller alkyl group along with oxygen that will be considered as the substituent, and the alkyl group which is larger, which has more number of carbon atoms, that will be considered as the parent. Now in this case, this smaller alkyl group along with oxygen that will be alkoxy, and this R which is larger alkyl group has greater number of carbon atoms, that will be considered as the parent and it will be named as alkane. It means that the ethers they also have two portions of their names. Alkoxy is from the alkyl and oxygen which is considered as a substituent, and alkane that represents the parent name of the ether. Now let's practice some nomenclature of the ethers. My dear students, in this first example, you can see that both the alkyl groups are same. So it is an example of the simple ether. In this case, you can select any one of the alkyl group with oxygen as the substituent, and the other alkyl group will serve as the parent. Now, my dear students, in this case, this one is methoxy. So it will be methoxy, and this parent has only one carbon atom in it. So it will be called as the methane. IUPAC name of this ether will be methoxymethane. Now, my dear students, this one is the second example in which the two alkyl groups are different. It is an example of the unsymmetrical ether. In this case, now the smaller alkyl group along with oxygen that will be considered as a substituent. This alkyl group has one carbon atom and this alkyl group has two carbon atoms. So the alkyl group with one carbon atom that will serve as the substituent, and the other alkyl group that is having two carbon atoms that will serve as the parent. Now this can be named as, this is methyl, this one is oxygen, so it will be methoxy, and there are two carbon atoms with single bond, so that will be called as ethane. Now in this case, methoxy is the substituent and ethane is the parent name. Now my dear students, again there is an example of unsymmetrical ether. The smaller alkyl group will serve as substituent and the larger alkyl group will be the parent. Now this alkyl group has three carbon atoms, and with carbon number 1, this methoxy is attached. You know that according to the recommendations of the IUPAC, the carbon carrying the substituent is given the lowest possible number. So you will start numbering from this carbon and it will get the lowest possible number as the substituent is attached with it. So that will be called as methoxy. Now with first carbon, this methoxy is attached, so it will be called as 1 methoxy, and the parent, that will be propane. So it will be 1 methoxypropane. Now, my dear students, in this case, again the smaller alkyl group is methyl, so it will serve as a substituent, and this alkyl group is having greater number of carbon atoms, so it will serve as the parent. Now, again, this one will be first carbon, second carbon, and third carbon. My dear students, the substituent is attached with the middle carbon, so you can start numbering from either side. Its name will be 2 methoxy, and this one is a 3 carbon chain, so that will be propane. It will be called as 2 methoxy propane. Again, dear students, in this case, both alkyl groups, they are same. It is a symmetrical ether, so you can select any one with the oxygen as the substituent, and the second one will act as a parent. Now, number the carbon atoms in the parent. The substituent is attached with the middle carbon, so you can start numbering from any side. It is 2. Now, my dear student, this one is isopropyl, so it will be called as 2 isopropoxy. And obviously, this parent has 3 carbon atoms, so it will be called as the propane. So it will be 2 isopropoxy propane. Now, dear students, in this case, this one is the smaller alkyl group. It will serve as the substituent, that is methoxy. And now this one is the alkyl group having greater number of carbon atom. It will serve as the parent. You can start numbering from 1 to 3, or even this can be the parent chain in this case. So you can see that with second carbon there is substituent. So it will be 2 methoxy, and with second carbon and methyl group is also attached, 2 methyl, and now there are 3 carbon atoms in the parent chain, so that will be propane. Its name will be 2 methoxy 2 methyl propane. Now, in this case, my dear students, again, let us see, this one is oxygen, and this one is the smaller alkyl group which is attached with this oxygen, so it will be ethoxy. And now the parent chain, that is having first carbon, second, third, fourth, fifth, and this one is sixth. So with the second carbon, alkoxy group is attached, which is ethoxy. It will be 2 ethoxy, 5 methyl, and the total number of carbon atoms in this chain, they are 6. So that will be hexane. So it will be 2 ethoxy 5 methyl hexane. My dear students, all these examples of ethers, they belong to the aliphatic ethers because the aliphatic hydrocarbon portion is attached with the oxygen atom. But these are the examples of 2 aromatic ethers. No, this one is, again, this alkyl group is having lesser number of carbon atoms. There is only 1 carbon atom in this alkyl group, but here are the 6 carbon atoms in this aryl group. So it will be called as methoxy, and now this one is benzene, so it will be benzene, that will be methoxy benzene. Again, this one is an example of a symmetrical ether, so you can select any of the ring as the substituent. It will be phenyl, and this one is oxygen, so its name should be phenoxy benzene. It will be named as the phenoxybenzene. So all these ethers, they are basically aliphatic, aromatic, but open chain ethers. Now the closed chain or ringed ethers, they are also called as the epoxides or oxyranes. And all cyclic ethers, they have three cornered ring. One of the corner will be occupied by the oxygen atom, and the other two corners, they will be occupied by the carbon atom. So there will be three membered ring in all of the cyclic ethers. And all cyclic ethers can easily be prepared by the oxidation of the alkenes. So that's why sometimes they are specifically called as the alkene epoxides, just like you can see in the books ethylene epoxide, propylene epoxide. All of these, they are prepared by the oxidation of the alkene. Now this one is the simplest of all the cyclic ethers, that is named as oxyrane. And my dear students, in the ring of this cyclic ether, the corner having oxygen, that is numbered as 1. And now the carbon having the substituent should get the lowest possible number. So it will be numbered as 2, and that will be numbered as the 3. So its name should be 2-methyl oxyrane. It will be 2-methyl oxyrane. And if you will remove one hydrogen from this carbon and you will attach a methyl group, it will be 2,3 dimethyl oxyrane. So in this way, you can name any ringed ether. My dear students, in this lecture, we have discussed examples of the symmetrical, unsymmetrical, aliphatic, aromatic, as well as the ringed ether. So it was all about the IUPAC nomenclature of the ethers. If you find any problem while naming the ethers at the home while practicing some questions, you can ask in the comment section. I will definitely be there to help you out. Till then, take care.